All right, this is the 7.3 addition and subtraction formula notes that we would have covered today in class. So we're going to start by, I have picked just one of kind of every type that we want to do, and then I've created a separate worksheet that you guys are going to complete and turn back in for points on Wednesday. Of course, you'll be able to ask questions as well before you turn it in. So let's look at this. It says our cofunction formulas. So this is trying to take advantage of the fact that we know that a triangle that has a right angle, all three angles add up to 180 degrees. So if you know you've already used 90 degrees, that means the other two angles must also add up to 90 degrees. And if you remember, sine and cosine are just two waves that are split off of what the pattern is by a 90-degree increment when you don't have any other transformations involved. So this is what this is saying. So the cofunction formulas say that the cosine of 90 degrees minus u, which is this one, is the same as sine of that angle. So they're saying if you make sine of this angle, which would be opposite over hype, a over c, that's the same thing as cosine of this angle, which is a over c. So tangent and cotangent, when you have a 90-degree split here, but the angles add up to 90 degrees essentially. Those two are equal, secant and cosecant, and vice versa. Sine, when you take a say 30-degree angle, is going to be the same as cosine of 60. So that's just what this is saying. So if the two angles add up to 90 degrees, then the sine and cosine, tangent, cotangent, secant, and cosecant of those cofunction angles would be equal. So let's use this fact. So it says express as a cofunction of a complementary angle. So we're looking at this first one that says sine of 15 degrees and 20 minutes. So we want to make sure we write that as a cofunction of a complementary angle. So we know we want to write sine as something in terms of cosine with a cofunction property here. So the question is, what is the angle that would be inside here? Well, it's going to be 90 degrees, take away this. So 90 degrees minus 15 degrees, 20 minutes. Remember, when we deal with minutes, we have to borrow a degree. So this is actually going to turn into 89 degrees, 60 minutes, because remember there's 60 minutes in a degree. Subtract 15 degrees, 20 minutes. So that would leave us with 74 degrees and 40 minutes. So that would be the cofunction of a complementary angle. So let's do the cosine one. We know that cosine has that relationship with sine. And then again, we would want to write this as we're going to go ahead and write 89 degrees, 60 minutes minus the 73 degrees, 12 minutes. So that's going to be 48 minutes and 16 degrees. So 16 degrees, 48 minutes. Okay, so for tangent, remember, it has this complementary relationship for cofunctions with cotangent. And since this is in radians, we're going to do, instead of 90 degrees, we're going to say pi over 2 minus pi over 6. So that's going to be getting a common denominator. And that would be 3 pi over 6 minus pi over 6. So this is going to be 2 pi over 6 or pi over 3. If you think about it, that makes sense because anytime we did the unit circle, we noticed that pi over 6 and pi over 3, their cosines and sines and tangents and cotangents were just flipped. So then the last one is secant, which would have cosecant. And this is a degree again, so we would do 90 degrees minus 17.28 degrees. Now notice we don't need to make this minutes because this is in decimal form. So we just need to think of this as borrowing. So this is 8, 9, 9, and 10. So this will be 2, 7, 2, and 7. So of 72.72 degrees. So that's how you work out the cofunctions of complementary angles. Okay, let's look at our next thing. So this is kind of just showing you this relationship. The rest of this unit section is focused on some formulas that we need to have memorized. Now, The good thing is that most everything else we do in the next few days, you can build them from the addition and subtraction formulas, mainly from the addition formulas. So we're thinking of these angles U and V, essentially two angles that we want to add together. And if you think about that visually, what that would look like. So here's an angle U and an angle V extra that we want to add to that. So this is U plus V all the way across. And we want to know what would it look like to take the sine of that angle, or the cosine of that angle, or the tangent of that angle. Now, I'm not going to go through the proofs because they're not hard. It's just that I'm going to post a video for it if you want to watch it. Essentially, the one that our textbook goes through is that it uses the distance formula. It imagines this being on a unit circle, and then it says, okay, what we really want, if we're doing the subtraction of two angles, is we want to know this distance to this distance right here. And they imagine making a chord on the circle, and they use the distance formula plus some other maneuvers to actually putting this in standard position. And they show you that the distance formula essentially gives us the subtraction formula for the cosine. So that's kind of how they go through it. And we're not going to be doing a lot of proofs in this class except for verifying identity. So what I'm going to do is just teach you some easy ways to memorize the formula because we're not going to have you prove it. So this first one is the cosine of the addition of two angles. It equals the cosine of the first angle times the cosine of the second angle minus the sine of the first angle times the sine of the second angle. So notice the cosines are sticking together, but the sign here is changing. It was a plus inside, now it's a minus. So when you're dealing with cosine, we like to say that our cosine is antisocial and disagreeable. Antisocial means that they don't mix. The cosines stay with the cosines, the sines stay with the sines. No mixing. Disagreeable means the sign changes. Notice that that is also true for the cosine of the subtraction of two angles. They're still saying cosine and sine, so they're not mixing, but the sign went from a minus to a plus. Now, what this is having you do and why we learn these formulas is because sometimes we want to do the cosine of, 15 degrees. And 15 degrees is not one of our unit circle angles. But 45 minus 30 is 15 degrees. So we can use the cosine of 45 minus 30 and plug it into this formula with the things that we do know from the unit circle, and we will be able to figure out what the cosine of 15 degrees is. So that's the purpose of this. And then we have our addition and our subtraction formulas for sine and tangent as well. Sine, right here, so sine's a little different. Notice that in the sines, the cosines and sines are mixing together. So adding the sine of u plus v, those are two angles. It's sine of u times cosine of v plus, so it keeps its original sign, cosine of u, sine of v. So sine is social and agreeable, because social means that the sines and cosines are mixing together. And notice that the u and v, you have one of those per part. A lot of people will mess this up and put both of these being a u. Not only do the sine and cosines mix, just like before, u and v are only represented once in each part. And then cosine and sine are mixing again here, but the sign is staying the same. So subtraction, sine and cosine are intermixing, minus cosine and sine. And it is important that you use sine u first instead of sine v, because this second part has a minus symbol. On this one specifically, up here, if you had a plus, the two fractions are going to add to the same thing no matter what. But when there's a minus here, that will change your signs if you're not careful. So make sure you do have these u's and v's in the correct location. And then tangent of u plus v and tangent of u minus v are found by putting these formulas of sine and cosine over each other and proving that it actually works out to this. So for the tangent, it's pretty simple. You keep it the same sign on top and you get one of each. On the bottom, it's always one, either minus or plus, and it's always the opposite sign on the bottom. and the two tangents get multiplied together. So again, normally in a class session, I would go through a little bit of these proofs, but we're really just wanting to make sure you guys have the most important part of what you should have had in class today, which is that you are learning how to use the formulas. So what we're going to do is we're going to go through some examples of how to use these. So for our next slide, notice we have sine of 2 pi over 3 plus sine of pi over 4. Now notice that's not the addition formula. These are two separate sines that are broken apart. This is going to help us with our second one. So see, this is kind of leading us into what we're doing here. So we know that sine of 2 pi over 3, remember 2 pi over 3 is over here, and that's a 60-degree angle. So in a 60-degree angle, you have the 1/2 for the x and the square root of 3 over 2 for the y, and over on this side x's are negative, but we don't care about that because we're looking at the sine value, which is the y value. So sine of 2 pi over 3 is square root of 3 over 2, and pi over 4 is right here. That's a 45-degree angle. That's square root of 2 over 2 and square root of 2 over 2 for the ordered pair. And that one, the sine is square root of 2 over 2. So this would be square root of 3 plus square root of 2 over 2 if we add it together. Okay, now that's adding these as two separate pieces. They both have their own sign. This is different. This is sine of one larger angle that we do not have on our unit circle, but 11 pi over 12 is 2 pi over 3 plus pi over 4. Now having to figure that out yourself can be a little tricky because you have to look at what could make something add up to 12. You could have had a 2 and a 6 for your two denominators that then got common denominators. There's not just always one way. Some people subtract to the angle, some people add to the angle. So that part does take a little bit of use if you don't already have the hint. So we're going to be doing the formula sine of 2 pi over 3 plus pi over 4. Remember, sine is social and agreeable. So it's going to start off with, if you want to look back at our formula, see right here, sine u cosine v plus cosine u sine v. So that's what you need to be using. So this would be sine of the first angle, which is 2 pi over 3, and then cosine of the second angle, which is pi over 4. Social, so we're intermixing sines and cosines. Agreeable, so plus. And then we have cosine of the first angle, which would be 2 pi over 3. And then sine of the second angle, which is pi over 4. So notice by doing this addition of using one big angle split into two pieces, we do have to include the cosine parts. So sine of 2 pi over 3 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. Plus cosine of 2 pi over 3 is negative 1/2. And sine of pi over 4 is square root of 2 over 2. Order of operations, you need to multiply before you try to add. So square root of 3 times square root of 2 is square root of 6 over 4. Plus, that would be negative square root of 2 over 4. So we get square root of 6 minus square root of 2 all over 4. And we don't do any kind of decimal approximations. We leave this as our exact answer. So you'll notice that this is different. This is a completely different problem than this. This is two separate evaluations. Both of them are unit circles. It's just two fractions that are going to get added together. Whereas this is one larger angle that's not typically on the unit circle, but by using the sum or addition formula for sine, we were able to split it into two angles that we do know and use the formula to figure out the evaluation. So that's kind of what we use this for. So let's look at some more examples. So this one is having us do cosine of 225 and cosine of 30 degrees. And we're just subtracting. Notice this is two separate ones. And then we're going to use that to remember you do the cosine of 195, the formula. So 225 is down here. And that's a 45-degree angle reference. So this is negative square root of 2 over 2, negative square root of 2 over 2. And 30 degrees is right here. And that is going to be a point of the unit circle of square root of 3 over 2 and 1/2. So then cosine of 225 means the x value only. So that's negative square root of 2 over 2. Cosine of 30 would be the negative square root of 3 over 2. because it's minus, but it really is just a square root of 3 over 2. And then that would make negative square root of 2 minus square root of 3 all over 2. So notice we're just adding fractions there. Okay, so then let's do cosine of 195, which someone decided to use 225 minus 30 since that does equal that. So this would be cosine of 225 degrees minus 30 degrees. Remember that cosine is antisocial and disagreeable, so we know it's going to have a plus in the middle. Cosines are going to stay together, so cosine of 225 and cosine of 30. And then the sines stay together, so sine of 225 and sine of 30. Cosine of 225 was negative square root of 2 over 2. Cosine of 30 was square root of 3 over 2. Plus sine of 225 was negative square root of 2 over 2. And sine of 30 was 1/2. So this is negative square root of 6 over 4, because we do multiply these. Here you were adding and subtracting, so you just keep your denominator. Here we're multiplying. And then minus square root of 2 over 4. So this is negative square root of 6 minus square root of 2 all over 4. Okay, so let's try, I'm guessing we're going to do a tangent next. Yeah. So the tangent formula was a little bit trickier. So we first need to figure out what we know about 3 pi over 4 and pi over 6. And remember, just finding a tangent, you do have to be more careful because you're looking at the ratio of sine over cosine. So let's figure out where 3 pi over 4 is, which is over here. It's a 45-degree angle. That means that this is square root of 2 over 2 with a negative for the x and square root of 2 over 2. But the tangent of that is going to be y over x. So that's negative 1 because it's square root of 2 over 2 over itself, but you have a negative x. So that means this one right here is negative 1. Pi over 6 is 30 degrees. So that is going to be, let's see, we just did that one. That was square root of 3 over 2 and 1/2. So 1/2 over square root of 3 over 2, multiply by the reciprocal. It's 1 over the square root of 3 or square root of 3 over 3. So that's the tangent of the pi over 6. So negative 1 minus the square root of 3 over 3, because there is a minus sign between those two. Now, we could get a common denominator if we want, but I'm not going to force you to. So that would be our answer for the first part. Now, while we're looking at those individually, is 7 pi over 12 is 3 pi over 4 minus pi over 6. And again, you can check this by getting a common denominator. Multiply this by, let's make these both 12. So multiply this by 3 over 3, that'd be 9 pi over 12. 2 over 2 would be 2 pi over 12. 9 minus 2 would be 7 pi over 12. So the formula for tangent is that you take the angles and you do exactly what we did up here on top. It's going to be tan of the first angle, keep your sign, so minus tan of the second angle. On the bottom, we're going to get 1 minus tan of both angles multiplied together. Okay, so we already know what the top is because we just worked that out. That's negative 1 minus the square root of 3 over 3. On the bottom, we get 1 minus, this would be negative 1 times the square root of 3 over 3. So this is going to be negative 1 minus the square root of 3 over 3 over 1 plus, because that's negative negative, the square root of 3 over 3. And then we usually clear out our denominator. So I'm going to multiply everything on top both by 3. So we don't want those little denominators. So this is going to be negative 3 minus the square root of 3 over 3 plus the square root of 3. And you could actually factor out a negative 1 on top. And this actually reduces because you get a matching binomial. So the answer to this one is actually just negative 1. All right. So we're about to move on to another type of problem where we may have to do some of the discovering of the angles ourselves. Oh, and before we move on, I just caught an error that I made. So let me back up real quick. I was not paying attention when I wrote my formula, and my denominator should not have been a minus. So let me fix this real quick. This should have been a plus because our original problem was subtraction. So that should have been the same sign on top and a different sign on bottom, which means this is not going to reduce down to what I have. So just a slight error on the formula. But that will make all the difference sometimes. So we all make mistakes. It happens to me too. So let's look at this. So it should have been plus right here. So that would not have turned into a negative or a positive on the bottom. It would have been -1 minus square root of 3 over 3 over 1 minus the square root of 3 over 3. We still would multiply top and bottom both by 3. And that's going to give me -3 minus the square root of 3 over 3 minus the square root of 3. And yeah, you could pull a -1 out of the top, but it's not going to cancel with the bottom because the signs won't match. So at this point, it's fine to leave it as it is. Some people will have you rationalize it. I don't usually get nitpicky in this unit on that. But this is what it should have been. It should not have canceled out because the sign up here does not match when you pull the -1 out. Okay, so now let's go on to the next slide. Okay, so this says express each trigonometric function as one angle. So we're supposed to figure out which formula did they expand this with and go backwards to what the original angle was. So notice cosines are together and sines are together, so that means this was originally a cosine problem. And remember, cosine is antisocial and disagreeable. So that means if this was a minus, it was originally a plus. So this is 6 degrees plus 25 degrees. This was originally cosine of 31 degrees. So you're just going backwards. Here you notice sines and cosines are intermingling, which means this was originally the sine formula. And sine is social and agreeable, so we keep our plus symbol. And this would be 57 plus the 4 degrees, so that is sine of 61 degrees. Okay. Let's look at our next example. This one says use the given conditions to find the exact value of the expression. So we are looking at sine alpha equals -5 over 13. There is a negative there. It's a little hard to see. So that's a negative. And tangent of alpha is greater than 0. And we want to find this. This is what we're trying to figure out. So what we're going to have to do to figure that out is we're going to have to draw the picture of where sine is located. So remember, all science teachers are crazy. Told you that was going to be important. Sine is negative in both quads 3 and 4, but we needed tangent to also be positive. So tangent is positive in quad 3 down here. So that means that my triangle, if I was going to draw it out, with an angle alpha at the origin, and remember sine is opposite over adjacent, so -5 over 13. We would use Pythagorean Theorem to figure out the rest. So this is 169 equals 25 plus x squared. That would be 144 equals x squared, so x equals 12, plus or minus, but for us, since we're in quad 3, it's going to be a -12. And the reason we need that is when we expand this formula, you're going to notice that not only do we need to know sine of alpha, we're going to also need cosine of alpha. So I'm going to go ahead and write what cosine of alpha is. Cosine of alpha is adjacent over height, so -12 over 13. So this formula, remember, sine is social and agreeable, so it would be sine of alpha cosine of pi over 3. Agreeable means we keep our sign. And then it would be cosine of alpha sine of pi over 3. Okay, so sine of alpha we know is -5 over 13. Cosine of pi over 3, in case you need a little remember, pi over 3 is over here as 60 degrees. And at 60 degrees, you get the 1/2 and then the square root of 3 over 2. So this would be, cosine would be 1/2 minus cosine of alpha, so that's what we needed this triangle for, which is -12 over 13. And sine of pi over 3, which is the y value here, is square root of 3 over 2. So then we multiply, this would be -5 over 26. This would be +12 square root of 3 over 26. So this is -5 plus 12 square root of 3 all over 26. Now, the only time you'll have to reduce something is if all three of the outside numbers are all divisible by the same thing. The 5 kind of throws that out. And that is our exact value. Remember, we are looking for exact, not decimal. Okay, let's look at our last one. So it says if tangent alpha is negative 7 over 24, and again, there's a negative sign there, and cotangent of beta is 3 over 4 for a second quadrant angle. So they're already telling you that alpha is in the second quadrant and a third quadrant angle, beta. They want us to find all three of the formulas. So the first thing I usually do is I draw a picture of alpha and beta. So alpha is in the second quadrant, and tangent's negative here, which makes sense. It's negative 7 over 24. And remember, tangent is opposite over adjacent, except I need to get my sign correct. In quad 2, x's are negative and y's are positive. So that negative in that formula came from the x-axis. So negative 24 and a 7. We would use quadratic formula to find the other piece. So that's 7 squared plus negative 24 squared equals c squared. That's 49 plus something that I'm going to figure out. So 24 squared, since it doesn't matter if it's negative, it'll turn positive. So plus 576. And this is one of those nice Pythagorean triplets, I believe, so it's going to come out nice. Yeah, it's 625, and the square root of 625 is just 25. So my hypotenuse is 25. The reason we need that is I'm going to go ahead and write what each of those would mean. So sine of alpha, because that's this angle right here, would be opposite over hype, so that's 7 over 25. Cosine of alpha is negative 24 over 25, and we already knew that tan of alpha was negative 7 over 24. Now we need to do the same thing for beta. We need to find out everything we can about beta. Beta's in the third quadrant, and we know that its cotangent or tangent, I'd rather do that, is 4/3. We'll flip that. So cotangent and tangent, remember, are reciprocals of each other. So beta would be opposite over adjacent for that. And since you're in quad 3, they're both actually negative. The reason we have to know that that turned out positive, though, is remember tangent is positive in that quadrant. And then two negatives make a positive. So then if we do our Pythagorean theorem, I already know this one, it's going to be 5. So 3, 4, 5. Because 9 plus 16 is 25, and 25 squared rooted is 5. So then we get that our sine of beta is, that would be opposite over hype, so that's going to be negative 4/5. Cosine of beta, it's going to be adjacent over height, which is negative 3/5. And tangent of beta, we already know, is 4/3. Okay, so we needed all of that so that we could quickly go through these formulas. So let's write out what each formula would look like, and then we're going to just plug and chug our pieces of information in. So this is sine of alpha plus beta, which, remember, sine is social and agreeable. So that'd be sine of alpha cosine beta, plus, then we would have cosine alpha sine of beta. I'm going to leave space for that one, and then we're going to have cosine of alpha plus beta is antisocial and disagreeable, so cosines are together at the beginning, minus, since we're changing signs since it's disagreeable, and sine alpha sine beta. And then the tangent of alpha plus beta is the tangent of alpha plus the tangent of beta, just exactly as you would think on top, one of each with the same sign, over 1 minus tan alpha tan beta, because you change the sign on the bottom and you multiply and subtract from 1. Okay, so let's plug these in. So sine of alpha, and try to go with my colors, is 7 over 25. Cosine, and I'm going to go ahead and plug in cosine of alpha. That's negative 24 over 25. Let's plug in the beta ones. So cosine of beta is negative 3/5 plus sine of beta is negative 4/5. Now you can obviously look to see if anything cancels before multiplying. It does not look like it does. This will be negative 21 over 125 plus, because it's negative times negative and a plus in the middle. 24 times 4 is 96 over 125, and 96 minus 21 is 75 over 25, which does reduce 125. Those are both divisible by 25, so that would be 3/5. Okay. And then we want to look at cosine. So cosine alpha, cosine beta. Cosine of alpha is negative 24 over 25. Sine of alpha is 7/25, so that's going to go over here. We have our minus sign in the middle. And we need cosine of beta, which is negative 3/5, and sine of beta, which is negative 4/5. We multiply. So negative 24 times negative 3 is going to be a positive. So that's 72 over 125. Negative and negative again is going to make a positive, and that'll be 28 over 125. So we add those together. That's 100 over 125, which reduces down to 4/5. So cosine of alpha plus beta is 4/5. Now, if you've gone through all that trouble, you could just get tangent by doing sine over cosine, as long as you trust that you've plugged everything in correctly. I'm going to go ahead and just show you how to use the formula, though. So tangent of alpha is negative 7 over 24. Tangent of beta is 4/3. Then on the bottom, we would have 1 minus tangent of alpha, which we know is negative 7 over 24, and then 4/3 again multiplied by that. So I'm going to kind of have to write this direction. So that's on top, negative 7 over 24 plus 4/3. On bottom, I'm going to think of that as just a 1 right now, but then this is 4 times of 7 will be 28 because it's negative times negative, so it's going to be positive 28 over, what was 4 times 24 times 3? That was 72. Now, if you wanted to, you could clear everything by multiplying top and bottom by 72, because it obviously goes into 24 and 3 since they both multiplied to that. So 72 divided by 24 would be 3, times 7 is negative 21, so that's my first number on top. 72 divided by 3 is 24, times 4 is 96. 72 times 1 is just 72, and then 72 in the bottom would cancel out and just leave me with 28. So that equals a total of 96 minus 21, which was 75, over 72 plus 28, which is 100, and that is divisible by 25 on top and bottom, and it's 3/4, which is the same thing you would have gotten if you put 3/5 over 4/5. So that one is kind of the culmination. It has all of the pieces and all of the formulas. And the main thing is knowing your sine charts really well so you know how these angles and all play together. So that's it. I will be posting this video plus the worksheet, and I'll see you guys on Wednesday.